To review the testing of proportions, let's begin with the CombiRx infection subset data from an earlier module. This dataset contains observations for 344 randomized participants to the CombiRx randomized clinical trial studying multiple sclerosis. The variables in this dataset include demographic variables as well as some baseline disease information. The main outcomes in this dataset are the presence or absence of an infection prior to randomization in the CombiRx study, as there is a thought that MS could be brought about by a latent infection. And so participants were asked when they enrolled if they had a history of these infections at all. So let's start by looking at the dataset. The first thing you would want to do is summarize your sample. And by sample, I mean the people that are in the data set. So once we make a judgment about the types of proportions and the frequency of the proportions, then we may want to say who this is applicable to, and that comes from summarizing the data itself. In this case, we'd go to the Analyze menu, Distribution, and we would put in all of our preliminary variables, our summary variables, and our disease information variables. So we're not looking at the outcome yet. We're simply looking at the types of people that are in our sample. And this is where you'd want to go through and see if you have any missing information in any of the variables. We know that we have 344 people in this subset, so we can scroll through relatively quickly and look for 344 people on each outcome, which there are. We could then record appropriate statistics such as the percentage of men and women, the mean age of those when they were randomized. If it's appropriate to the question you're asking, perhaps some information about the type of the participant or their marital status or their health insurance status. And then particularly if you wanted to look at the number of years since diagnosis for those participants. So there's a few things here that we want to look at, one of which is age at baseline and age group at baseline. Sometimes treating age as a continuous variable doesn't really get at the question you're asking, and you'd like to treat it as a categorical variable. Here, our age groups are listed as group 1, 2, 3, and 4. And that's actually tricky because I don't know what that means, and I also am fairly certain that the difference between age group 1 and 2 is not the same as the distance between age groups 2 and 3. So how do we go about labeling those groups to be something more meaningful? Well, first we need to know what our groups are, what the levels of our groups are. So you could check if you had a data dictionary. In our case, we can simply do a fit y by x, with the age group at baseline being our x variable and the age at baseline being our y variable. Age at group as x, the actual age as y, and press OK. And then ask simply for the quantiles. So under the red arrow, ask for quantiles. And you can see here that age group 1 has a maximum of 29 years of age, and age group 2 actually starts at 30. Age group 2 stops at 39. Age group 3 starts at 40. Age group 3 stops at 49. Age group 4 starts at 50 and ends at the age of 60. So right away we know that this sample includes people from the ages of 18 to 60, and we've determined what our age groups are. So now in order to rename that age group, I'm going to select the age group variable and jump, and then I'm going to go into the columns menu and column information. What I want to do here is actually add some labels. So value labels under column properties, and for the value of 1, I am going to make that label 18 to 29 and press add. And for value label 2, I'm going to make that variable 30 to 39 and press add. And for 3, I am going to make that 40 to 49. And for group 4, I am going to make that 50 to 60 and and press add. I also want to change this to a character variable so that I can get proportions instead of means out of my 1, 2, 3, and 4. And I'm now going to press OK. And when I press apply and OK, when I press apply, you'll see these age groups suddenly change to be their corrected groups. And I will press OK. So that is how we would make the age group go from a number to a category that's helpful to us. We would also want to write up a description of the number of people, any missing data, and any relevant statistics. So let's move on from here to testing a single proportion. So let's say that we know that the proportion of people with relapsing remitting MS that are female is 70%. This is in the general population. 70% of those with relapsing remitting MS are female. We have a distribution of gender here, which I can do analyze, distribution, and gender, and press OK. And so I can see from this that my proportion is 0.71. If I wanted to test this versus 0.70, the assumed proportion of females, I would go up to this red arrow under gender and ask for test probabilities. And then I want to test 0.70. Now, since I don't know in advance if my proportion is going to be greater than or less than 0.7, I've planned in advance to do a two-sided test. That is probabilities not equal to hypothesized value. So I'm going to ask it for a two-sided test, equal to or not equal to, and press done. And you can see here with the likelihood ratio test, and that's the chi-square test that I want to report, the likelihood ratio test tells me that if my null hypothesis, if my HO is that the two proportions are equal, our observed proportion of 0.71 and our assumed proportion of 0.70, that's the null if they are equal, and our alternative is that they are not equal, then my large p-value here, which is greater than 0.05, this p-value here, it's large, will refer me back to the null hypothesis. And so my conclusion here, at least in terms of gender, is that our breakup of gender is not different from the assumed relapsing remitting gender breakdown, which is 70% female, 30% male. Notice I didn't say we have shown or proven that our proportion is 0.7, or we have proven or shown that our proportion is the same as 0.7. What I said is our proportion is not different from the assumed proportion of 0.70. And that is how you test one proportion using JUMP. Now, what if I need a confidence interval about those proportions? Again, under the red arrow, there's a confidence interval option. Because my alpha is 0.05, that's the alpha for my test level, I want to use a 95% confidence interval. And from there, JUMP will simply give you the confidence intervals. Now, these are score confidence intervals. So when you write up your results, it's important to say using a 95% score confidence interval. We've observed 71.2% females, and we are 95% confident that the true proportion of females with relapsing remitting MS ranges between 0.66 and 0.76, or ranges between 66 and 76%. And of course, that is in line with the assumed 70% females. That is all you need to do in the analysis menu for testing a single proportion.